Hello guys, welcome back to the channel for a new Databricks video. Today's video is about incremental load in Databricks. We did a similar video in the past regarding incremental loads in Databricks, but it was based on mount points and not Unity catalog tables. But things have changed since then. Databricks is pushing everyone to move to Unity catalog. So, in our example, we are going to showcase two ways of performing incremental loads or historical loads in Databricks. The first way is by using CDF, Change Data Feed, as a feature on Delta tables. Then it's easy to propagate, to perform incremental load, but also propagate deletions and updates. The second way is the old-fashioned way, where we don't have Change Data Feed as a feature enabled on a Delta table, and we can easily perform incremental load by keeping versions between the source table and the target table, but we cannot propagate updates and deletions. If you want your target table to reflect the source table, then you have to perform a full reload. So let's get down to the nitty-gritty. Okay guys, so here we are on our Databricks workspace, and this is our first notebook. The first thing we have to do is create a data frame and save it as a Delta table in Unity catalog, and the first case would be by using Change Data Feed. So we have to enable the Change Data Feed feature when we create this Delta table. So here is our dummy data. We have four columns: the ID column, the department column, the value column, and the date key column. ID is an integer, department is a string, value is an integer, and date key is an integer as well. So here we create our dummy data frame, and here we use df.write.format, delta format. Apparently we override the schema because this is the first time we create the Delta table, and then in the option we enable Change Data Feed. So here option delta.enable change data feed equals true, and then we partition by date key and we save this as a table, so the bronze table. So let's save the data on this bronze table, and here remember in the medallion architecture on the bronze layer we have the data as we get it in the same format we get it from the sources. So we gather all the data from various sources and we store it as it is. Now let's actually see the data, select from the bronze table, and here we would see 3 records. Yep, as you can see. Now let's use the describe history command here, and as you can see we have only the 0 version, which is the create table as select, and then here you can see the operation metrics, right? The number of files, output rows, etc, etc. So this is 0 version 0. Now if you want to select all the changes from the change data feed table, you use select from table changes, table underscore changes, then you specify the table name, and then here you specify the starting version. Now the starting version is 0, and here you will see all the data plus 3 more columns, the change type, which is insert or update or delete, and actually it has also one more type, which is before the update and after the update. You will see in a little bit. And then we have commit version and then the commit timestamp. Okay, so let's say now we have the data, we have enabled change data feed on the bronze layer, on the bronze tables, and now we need to propagate all those things to the silver layer, right? So you want to perform incremental load. How can you do that? So the first thing here, we have developed a small framework, you could say. Let's say you have this primary key, you provide the primary keys here, the input table, the version table, the partition key, and the output table, and the schema of the data frame. Now, what's the version table? Input table is the bronze layer. Apparently, we get the data from the bronze layer. version table is an extra table that we are going to store the versions that we have moved, that we have gotten, we have got the data from the bronze layer, and we have moved the data to the serial layer. So what we do is we store the version that we have already loaded on this version table, and then we compare the version of the bronze table. As you can see here, we have version 0, right? So we compare the version that we have on the bronze table once we have something new. So when we update this bronze table, it will create a new version, right? So then if we, now you will see in the first load, we are going to load all this data that we have here. We are going to load the data as it is from version 0. But on the source table, on the bronze table here in this case, we are going to insert some new data, update some new data, delete some data, and it's going to create new versions. So what we do is we compare the version that we have on the source table and then the version that we have stored in the version table, and we compare the versions. So whatever version we are missing in the version table, then we load it to the serial layer. Okay, so how can we do that? So let me actually remove this, it's not necessary here. And here we have, now we pass all these parameters into this function here, and then we create an object from this class changes, right? And we pass all those parameters, the input table, output table, version log table, the primary key, and the partition key. So here, if we go into this changes class, which is a big one, and this is a very important one. Here, as you can see, first, it determines the changes that happen on the delta table to only process changed data. The purpose is to actually get the data from whatever data we are missing on the source and move it to the next step, the serial layer in this case. First, we provide the log schema, which is the version, so we keep track of the versions and the event they type. And here in the init function, we pass the input table, the output table, the version log, we have the primary key and the partition key, all good here. And then here we retrieve the current version of the source delta table. Now what that means is we use delta table for name, so then we have spark and input table history collect, and we get version from the source data, right? Which is here. So describe history, bronze, and then we use, here we have history and then collect and the version. So essentially we get the data, the latest data from this column, the version column, using the history command in PySpark format. And then also here we can check whether CDF is enabled, if change data feed as a feature is enabled in this table, because if it's not enabled, and we will see that in a bit, we are going to use a different technique, a little bit different. But here we use describe detail, and then we pass the input table, which is the bronze table here, and then from properties we get this if change data feed is enabled. So if you describe, okay, so let me copy that, describe detailed describe extended, sorry, that goes in PySpark format, describe extended. Here at the bottom you have table properties and you see change data feed is enabled, right? Okay, and then what do we have? So first, let me actually run the code. Okay, it's running, so in the meantime, let me explain you the logic of the changes classes. So here, as you can see, we have all those parameters. First, we get the current version of the source table, and we store it in this variable here, new underscore delta version. Also, we check if CDF is enabled in that table. And then we get the current version of the table in the log table. We keep track of the changes of the source table. So here, this table version variable, we use spark.table, and then here we check the version log table here. We order by the last event date time, and then we get the latest version that we have saved in the log table. So let me scroll down and select from the server table, and here we will see the same data exactly, right? Perfect. And now, as you can see, in this log table, we have stored the version 0, and we have also version 0 on the source table here on the bronze table, right? Perfect. So let's go back to the code. What we do is first we compare the versions. If the new delta version is less than the table version, then we perform a full reload. And here, if we scroll down, okay, so here, let's go back to the bottom, and here what do we see? We get the latest data, right? Remember here, we pass all those variables in this function here. We instantiate the changes object, and then using this object we call the get latest batch, and here we have this function. So if the table version equals -1, then we load all the partitions. So we are going to load all the date keys, right? So we have here on the bronze table we have two date keys actually. So we are going to load all the data. Now, if we have CDF enabled, we are going to use this select table, table changes underscore changes. Then we specify the table name, and we load the data from the version that we want, instead of checking all the partitions that we are missing, right? So here, get all partitions. Let's go back here, and then we check if change data feed as a feature is enabled. Then let's go back here, get table changes data. So we have a function here, and then we pass the version. So if CDF is true, then we here we define the change type column, the order key column, which is the commit version, and then we perform this query, right, as you can see it here. Now we select everything from table changes. From the input table we specify the version. In this case it was 0, where the change type is either insert, either post update, or delete. And then what we do is actually we have to partition by the primary key, or whatever columns that you have that make sense business wise, and we perform a window function because we only want the latest data. For example, if we have two updates in one record, we want the latest update, right? We don't want both updates because we want to have the latest record. So that's why we have to perform an analytical function to get only the latest changes. And here, as you can see, we perform this query from the table underscore changes from the version that we want. Then we rename the update post image to update. That's for you if you want. And then we use the row number function analytical function to get only the latest version, then we drop this RN column here. And if there is an exception and something happens that we don't get any data for that version, then we retry with version 0. So we load all the data again. And if we scroll down here, I have already printed a few things. So you can see the table version in logs is -1. The original table version is 0. So we compare this and then we select from table underscore changes the bronze table from version 0, where change type in insert update post image delete, right? So target table, before the merge we don't have anything, and then after the merge this is the source dataset, and then we use this merge request, which is merge into target using source, and then based on the primary key here we match, and if the change type equals insert or update, then we update everything except those columns here, because we don't want to propagate those columns. You might do, but in this case we don't. So we accept those columns. When matched and the change type equals delete, then we delete, and when not matched and the change type equals insert or update, then we insert everything except these columns again, these change data feed columns. Now if we scroll up, as you can see here, first we get the latest changes, which is using this query here, select from table changes, and so we have the latest changes, and then we create a merge object that we pass the schema, the primary key, the partition, the output table, and if we want the target table to be if we want the target table to have change data feed enabled. In this case we don't want the target table to have CDF enabled. Only the bronze layer has, only the source table has CDF enabled in this case, and then we execute, right? So we execute. So if we go into the merge class here, you will see then we pass in the init function, we pass all those attributes, and then if the table doesn't exist, the target table, then we create an empty table, right? We override the schema, we pass the parameter here if we want it to have CDF enabled, the partition key, and then we create an empty target table, and then in the execute we check if there are no records, then it doesn't make sense to do anything, then we return. If there is no target table, so here that's the difference between mount points and unity tables, you have to use spark.catalog.table exists, and then we override the output schema, which is the function that I mentioned here, that we create an empty table, target table, and then we load the target table, which is empty, then we load the source table, then we have the source table that we pass at the bottom, and we create 2 temporary views, and then here we create the merge statement all with all those parameters and the except columns here that we have, right, which is this one down here. So merge into target using source based on the ID column, and if it's matched and the change type is in insert or update, then update. If it's matched and then it's delete, then we delete, and if it's not matched and we have insert or update, then we insert, right? And this is how we can see the data on the receiver layer. So let's run it again and see. Here is the 3 records that we have on the bronze layer. Now this version table here, as you remember, at the bottom here I have this create log record. So if we go here, create log record, we create a data frame, and then we just save, we append the version that we just loaded. Now it's time to perform some insertions, updates, deletions, and see how we can use change data feed. Okay, so let's insert a new record. Into the bronze layer, we have ID equals 10, then test, and then we have 3 and a new date key, right? And then let's update this record. Let's set the value to 200 where ID equals 1. And then also update the same record and set the value to 300 this time. So 2 updates in one go. And then let's delete the record with ID 3 from the bronze table. So now if we select from everything from the bronze table, you will see we have 3 records. We have a new record, we have the latest value for ID 1, and call and record with ID 3 is deleted. Now if we perform this, if we select all the data from the table changes using this CDF feature, you will see here we have from version 0 we have all those changes, right? We have this column here with this record here with ID 1. You can see we have update pre-image, update post-image from 44 to 200 and from 200 to 300, right? And as you can see, with each change, we have a new commit version, right? And then here you can see everything is inserted except this one that got deleted. So commit version 4, we deleted this record with ID 3. Now if you describe history, here we have version up to 4, right? With all those changes. Write, update, update, delete. Insert, update, update, delete. So now we want to propagate and those changes and perform an incremental load on the serial table, right? So how can we do that? Now the serial table is still the same. Here, as you can see, we have the original records. And then here, as you can see on the version table, we still have version 0, right? So now we are going to compare version 0 with this version here, which is 4, and we are going to load all the changes from version 1 to version 4. So all the changes that we have for version 1, version 2, version 3, version 4. Now let's run the same code for the serial layer again, and we expect the serial table to be updated with the latest changes. As you can see, table version now on lows is 0, original table version is 4. So then we select table changes from 0, right? And then all the changes here we have these changes from the change data feed. We have the change type equals to update, and then we have insert, delete, insert. Right? Only one update with the latest value, because remember we performed an analytical function here to get the latest data. As you can see, we have the raw number function here, the analytical function, we get the latest data. And then we perform a merge with all those conditions, right? And let's actually see what we have on the serial layer right now. We expect to have identical data with the bronze table, exactly. So we have this new record with ID 10, and then this record with ID 3 got deleted, and the value for the record with ID 1 is 300, so we got the latest update for this record. And now if we check the table with the versions that we store the versions here, as you can see, we have version 4, right? This is the latest version. Now if we perform, let's say, a new update and a new insertion. So let's see. Let's say we perform another insertion here, and let's describe the history of the bronze table. You will see now that we will have version 6, right? We have 5 and 6. In version 5, we updated one record. In version 6, we inserted one record. Now, again, here in the table version, we have 4. If we run this code again, it's going to compare the versions that we have. As you can see, the table version in logs is 4, and then the table version in the source data is 6. So we compare the versions and we load the latest changes. And here, yeah, let's select everything from the serial layer, and we got the latest changes as well, as you can see here. Okay, so let's say that something happens now, and then we delete those records. So let's delete some records here. Delete from silver, where ID in 1, 10, 11, right? So let's delete those records. And here we will have only one record. And let's say someone dropped these records accidentally, or there was a purpose or whatever, and you want to reload all the data. You want to perform a historical load and get again all the data from the beginning. Remember that we have this version table here with all the versions. Now, how you can perform a historical load? It's pretty simple in this case. You delete from the version table where version greater and equals to 0, right? So we truncate the version table. Now we don't have anything here, and then we just run the code again. It's going to reload all the data from the beginning. So from version 0 to version 6, it's going to reload all the data, and it's going to merge it to the target table. So now we expect again to see the latest data. So let's see what we have on the serial table. Here we have all the latest data again, because we perform a historical load. So we loaded all the versions from version 0. And this is how you can perform a historical load. It's pretty easy using a version table, an external table, to keep track of the versions, and then you compare the versions with the versions of the source table. And if something happens to the target table, if someone dropped the records, truncated the table, that, well, believe me, it happens, then it's very easy to perform a historical load. You truncate the version table, and you perform a reload with everything. So it's pretty easy. Okay, so back to the bronze layer. Now let's create a new table, but without CDF enabled, because we need to be able to perform incremental loads and historical loads the same way that we perform using CDF. I mean, with the same results. It's a different way, and do it as, let's say, as productively as when we are using change data feed as a feature. So here we create a bronze table, as you can see, and we disable the change data feed feature. Right, so let's create this bronze_demo table without change data feed. So a normal delta table in Unity catalog. Okay, so here on the silver layer, we also only change the input table name, the version table name, the partition key, and the output table name. So we don't change anything in the code. If we run the code, we expect the serial layer to have the same data that we have on the bronze table. So let's actually select from the bronze table to see the data. And here you can see the same data. Now if we select from the serial table, we expect the same data, exactly, right? Now, the change here in the code is when we have here, as you can see, changes instead of selecting from the table underscore changes from when we have the CDF feature enabling a table, we get the latest changes from table underscore changes, and then we provide the table name and the version, we get all the latest changes. But here, what we do is actually load the old data with the version that we have stored in the table version, and then a new data with the latest version here, and then we get the max date key. And if the max date key from those two, from the old data and the new data, if it's the same, then we select from the input table all the changes with the latest date key. This happens if, since date key refers to a certain specific day, we partition by specific day. If we load data, if we run the code multiple times per day and we have updates multiple times per day, then this is the case that we want to load only the latest date key. But if it's not, then we compare from these two versions, from the old data and the new data, we compare the date keys using a left anti-join here, and we get the changed partitions, and then we select from the input table where date key is in those partitions. Now, the first time we only have these two partition keys from the bronze table. Here, as you can see, we have 21 and 20 as partition, as date keys, distinct date keys. So we load all the records with those date keys. And here we also have on the version silver table, we have stored version 0, right? Now, if we perform again the same update, so we update this bronze table with this new record, we update it again, insert, update, and then delete. So we perform the same actions that we performed before. And here you will see all the data on the bronze table, the updated data. We have 3 records with this value here and this new record. Now, if we run this code here, we run this merge statement, right? So we compare the versions and then we compare the changed partitions. So we select everything from this changed partition, which is with this date key, right? So this is the changes here, the new records. So if we select from the silver table now, you will see that we get the latest records. So we perform incremental load, but we do not propagate the updates and the deletions, right? So we still have this record. We didn't update this record here because without using CDF, we can only perform incremental load based on the partition key. There is, of course, another way to propagate deletions and things, but in this case, this case can only be used for incremental loads. Now, for example, if you're going to actually see the updates, what you can do is actually drop, the target table again. So select from silver demo 2. Okay. So here you will see the latest version that we have in the table that we store the versions. This is version 4 is the latest source version as well. Now, if we truncate this table that stores all the versions, and if we from the serial table, if we delete everything, so 1, 2, okay, truncate or whatever, 311, so if we truncate the table, and here we select again, from here you see now we truncated the silver table, the target table, and we also truncated the table that we store, we keep track of the versions that we have loaded. Now here this should be empty, right? Now if we run this code again, it's going to reflect the latest changes. So we load all the partition keys 20, 21, 23. So now the target table here, the serial table, should reflect the changes that we have on the bronze layer. And yes, it does, right? But in order to actually have it doesn't propagate updates and deletions. So if you want to also use it to reflect the latest changes, this is not the case. We can perform incremental load, and then if you want to propagate all the changes that happen on the bronze layer on the source table, then you have to drop the target table, truncate the version table, and then reload everything and perform a full reload. So this is a limitation in this case where we don't have change data feed enabled here, right? So we haven't enabled change data feed, so we cannot propagate deletions and updates. This is it for today, guys. I hope you enjoyed the video and you learned something new. Of course, there are many ways to skin and count and perform incremental and historical loads. These are two ways that I have been using. I recommend to use change data feed as a feature now that exists, and it's easy also to propagate, updates and deletions. In the other case, it's perfect if you want to perform incremental loads or you want to perform historical loads. But again, you cannot propagate updates and deletions if you haven't truncated the target table and the table that we store the versions and perform a full reload. If you like the video, please click the like button, subscribe to the channel, leave a comment, and I will see you in the next one. Thank you.